Yeah, I want to thank everybody for joining us for today's webinar sponsored by Astrix entitled Maximizing Efficiency, How Lightweight Business Process Mapping Can Minimize the Cost and Risk of a New LIMS Implementation. Today's session is presented by Eban Tomlinson. He's the Director of Sales and Marketing at Semaphore Solutions. And again, it is sponsored by Astrix. So we go to the next slide, please. So before we get into the session, if you're not familiar with Astrix, if this is the first webinar that you're joining us for, we'd like to welcome you. If you're coming back from another webinar, we're glad to have you back again. Just in terms of who we are as a company, why are we doing these webinars? Well, first and foremost, we're a consulting company and we do professional services work. We do it exclusively in the life science space. In fact, over 90% of the employees that work for Astrix hold advanced science degrees. And for the better part of 28 years or more, we've been serving the scientific community. What we do is we help organizations find, select, implement, upgrade, optimize, test their technology stack. And that's going to be predominantly the technology stack that drives and runs their R&D departments. But we can go outside of that as well. We go into certainly clinical research and other areas than just business process optimization. But that's generally who we are. We work with a wide array of technologies on the market, like our friends from Semaphore today, who you're going to hear from in just a moment. So that's just a little bit about who we are. We produce a lot of content like today. We try to dedicate a portion of our efforts and energy on educating the industry on kind of what's coming down the pike in technology and what are some of those best practices. So that's a little bit about who we are. I'd like to now introduce our speaker for today. You can go to the next slide, Evan. And Eban Tomlinson, he's, again, as I mentioned, he's the Director of Sales and Marketing at Semaphore Solutions. He brings over 20 years experience designing, implementing, and working with business critical informatics systems across all manner of regulated industries. Computer science background, over a decade experience in life science laboratory informatics. So we're certainly glad to have him. I'm excited to hear from Evan today. I'm going to sit back and listen to the presentation, and Evan, I'll pop back on at the end to help with some questions.
Thanks, Kevin. Really appreciate it. Hi, everyone. And once again, thanks, Kevin, for the intro. So here's our rough agenda. We're going to explore first why I find text-based requirements to be inadequate. One might say wholly inadequate, but that's kind of the point of this. We're going to slowly move to introduce visual workflows and sort of how we got into this space from the Semaphore side and why we think they're a natural choice for representing informatics requirements. And then we're going to work through the lightweight approach to business process mapping that you're all here for. I'm also going to apply that framework to a practical example from the Electronic Code of Federal Regulations, and we're going to follow that up with a walkthrough of what we at Semaphore call a communication diagram. That's an artifact that we create when we're selling Labit, that's our LIMS platform, our informatics platform, that we use to manage risk and control costs when it comes to implementations. We found it nets us out some pretty significant benefits in terms of understanding and alignment. And really, it's the artifact that I'm essentially recommending that you use in your next informatics implementation or informatics project. And then we're going to wrap it up with some realized real-world benefits that our Labit customers are seeing from utilizing visual business process mapping in their LIMS, because Labit puts visual business process maps right front and center. So let's jump right in. This little comic, it kind of underpins the entire point of this webinar. I lifted it from a presentation by Dr. John So. He's a computer scientist and mathematician, worked with IBM for many, many years, but he's focused on the graph representation of knowledge and artificial intelligence, that is to say, reasoning with artificial intelligence. The important point that he's making here, and that I really want to echo, is that our written language, it's really not ideal for communicating, and that emphasis is important, communicating complex spatial patterns like requirements, for example. It works well to represent them, but that emphasis on communication is really one of the key points here. It's been my experience that a lot of laboratory scientists don't tend to think of challenges in the laboratory and how to apply informatics to them as spatial patterns, or even more specifically, those informatic projects, such as like a new LIMS implementation, is a spatial pattern. But I'd challenge you all to consider it though. Your laboratory, it's a physical space with physical entities within it upon which you're performing experiments and taking measurements. Framed differently, you're receiving, processing, and eventually archiving the physical entity, and the data produced from the physical entity itself is transformed over time in a workflow, which in our opinion is best visualized as a flowchart or a string of interconnected steps. So why then is it that when a new customer comes to us at Semaphore thinking about buying Labbit, for example, and asks us to bid on their LIMS or informatics project for the consulting side of our business, why is it that they try to describe what they're doing using text or words rather than diagrams? The problem, it goes quite a bit deeper than just showing up with text and or a verbal description. It's the follow-on impacts of using a text-based description rather than a diagram to communicate a laboratory's needs, and in turn evaluate if a software package or a project will fit the required use cases. This is a real example that I'm going to go through later I'm going to apply the framework to later in the webinar. You see 467 words on the left, and it's condensed into 4 activities in a single branch on the right, which in turn communicates so much more about what's expected of your staff. We're going to go through this example, as I mentioned. The point with this is that really a picture is in fact worth 1,000 words when it comes to communicating concepts and in particular expectations within a workplace. Of course, 467 words in this case, but you know, let's take some license there. So let's talk about what you, the laboratory, can control though, because this is what this is about, right? How can we control costs and risks in a LIMS implementation or an informatics project? As a software vendor and also a service provider that builds custom software, we think about the cost of software in 2 distinct categories, and that's regardless of whether it's an ELN, LIMS, LIS, SDMS, or some other acronym. It doesn't really matter which one. The first category of costs is the license cost, which itself is not so much a risk, and it's really not something that's within your control beyond the negotiation. And furthermore, it's something that's easily compared between vendors. So I'm not going to dig further into license costs. But the second category, and this is the area that I want you all to take back control of by applying this framework, is the cost of the project to implement that scientific support system, and in particular to custom configure it to be exactly what the laboratory needs. That is to say, to match up with your requirements as they're understood at the time that the project is quoted. So one of the things that we do in computer science and project management as disciplines a lot is the failure analysis of projects involving computers. It's commonly held amongst software professionals that up to 75% of software project failures can be attributed in whole or in part to missed or misinterpreted requirements. And this is something I wholeheartedly agree with, but of course none of my projects have ever failed. But still, it's important to note here that I'm not putting blame at the feet of the folks on these projects implementing them, nor the salespeople who sell them, nor even the laboratory folks who are commissioning these projects. Instead, I think the blame lies on the over-reliance that we as humans have on text-based lists, and in particular spreadsheets, or more specifically, requirements lists. You've seen them before. As a user, I want to accomplish X or Y, or system shall do A, B, or C. The blame is on these text-based lists because they form the basis of the legal agreements that these implementation projects are based on. And specifically, the blame is that those lists don't communicate well. They don't communicate what you're trying to accomplish or your goals. They don't accomplish that end-to-end flow that we need in a laboratory. We've had the power of multimedia since at least the advent of the personal computer in 80s, 90s, take your pick really, and arguably before that even. So why then do so many labs show up to buy a LIMS with nothing more than a list of requirements for what is often a half or even $1 million purchase? For context, like up to 70% in any given month will show up without documented requirements, even in a list form, never mind a diagram. So that's why when we're selling Labbit, we get around this oversight by moving as quickly as we can to diagrams. And that's because of the consulting side of our business. And I'm sure our Astrix colleagues share this. We've noticed a pattern, and it's emerged across the numerous laboratories that we've worked with. We always start a conversation around requirements or a LIMS implementation project with words, but then inevitably I or my counterpart or one of my colleagues, one of us reaches for a whiteboard. This image is one from a real analysis performed for a client now using Labbit, with all proprietary information redacted, obviously. But that diagram in pink, that's the first stop that a lot of humans go to when they're trying to explain something complex, when they're trying to communicate to be understood. Again, communicate to be understood, not just sending over a list of requirements and hoping it works. So specifically workflow diagrams. I think this is the important part here. This whiteboard is a great example of how we as professional consultants would begin to gather requirements. We'd sketch out something at a high level like this, and then we'd work to iteratively define it by digging into each individual box within that high level flowchart that exists there over a series of sessions. That iterative framework we use is what I'm going to get to a bit later. Ultimately, the point here is to work toward a concrete picture of how your lab works so that we as vendors can adapt your informatics to the process you need it to do, rather than the other way around. You shouldn't have to adapt to your informatics should adapt to you. Let me reframe that. Imagine for a second if the informatics you used in your lab were perfectly fit for what you were trying to accomplish, rather than you having to dig through manuals and sit through user training sessions in order to understand how to utilize it. That's the power of business process modeling, or BPM, of thinking in terms of workflows and the entities that flow through those workflows, like samples or reagents or instruments, rather than what a LIMS, an SDMS, or an out-of-the-box module will accomplish for you. This is another example, and this will be the last example before we get into the practical parts of the tooling, but this is another diagram that serves to communicate, I think, better than words. This is a whiteboard diagram my colleague Juliana created to help me, as a computer scientist, understand what's happening in the NovaSeq library prep workflow, coming from the reference guide you see on the right-hand side. She explained what was happening during each bench operation you see in the boxes in the upper left there. And as the arrows indicate the flow, and it's sometimes branched depending on what you were trying to do. Now, what if I told you that this diagram that you see here could be used to run your lab informatics directly? We're here to talk about business process modeling, and in almost all cases, business process modeling is accomplished using a notation called, unsurprisingly, business process model and notation, which is an open source workflow specification. BPMN is easy to learn, and this diagram that you see on this whiteboard, it's actually already almost a formal BPMN. And in fact, here it is as that formal BPMN. A BPMN is a visual model of a process that's stored as an XML file. That's an important point that I'll get to in a bit. Because it's an open source standard, you can create it in Visio or Lucidchart or Camunda, to name a couple of names. There are many free number of diagramming tools available online or through your favorite software provider that lets you create these things. The most important thing to know about BPMN is that because it's stored as XML and represented visually, that XML component means that it's directly executable in software without any further configuration. And the conditions for routing are specified unambiguously in the diagram itself. I'll call your attention over on the far right-hand side to that greater than 600 base pair just under the diamond, indicating a conditional process split. As you can see, it's a relatively intuitive vocabulary of symbols which can be used to communicate simply what is normally a huge amount of text-based information. And once that process model is complete, you can, in theory, use it right away. Even if your informatics system doesn't directly support BPMN, you're still going to realize benefits by mapping out your workflows end-to-end in a process diagram. That's improvements in clarity and understanding of how your lab works as you train new staff and onboard them, or communicate new requirements to your IT colleagues, for example. BPMN provides a powerful tool for analysis in your continuous improvement programs, helping you identify bottlenecks and areas for potential improvement or standardization, as well as providing a foundational point from which you can critically evaluate if a new informatics package or a new informatics project is going to work for your team in improving an outcome. So formally, what is BPMN? It is, as I mentioned, an ISO standardized way of representing the activities or steps taken upon a real or virtual entity. In this context, that could be the common sample that we all know and love and work on in laboratories, but it could equally be anything that you want to manage or work on. Indeed, all software packages that have the word management somewhere in their name or category name, they're fundamentally workflow engines that have a database of some kind attached to it for data storage and auditing purposes. So BPMN is this clear and unambiguous language of boxes, arrows, and decision points that can be intuitively understood and therefore used with minimal training. There's a formal specification that goes well beyond what you see here, and by leveraging all of that specification, you can capture any level of complexity and activity-based interactions into a workflow. The real power of BPMN is that, like business process mapping, it is not limited to any one category of software and the arbitrary boundaries imposed by it. LIMS, ELN, SDMSs, freezer management systems, all of these are rigid software applications that implicitly specify a workflow rather than explicitly and generally specifying workflow. I say this with confidence because our platform Labit, which directly uses BPMN to control its workflow within it, has been successfully implemented in all of these software categories I just mentioned. So think about that. What if you didn't need all of those different software applications like you have to work with every day? What if you could just specify a workflow that you wanted to have in software and it just worked? I think that's a pretty powerful idea. So let's dig into those tools. Let's get practical. I promise to equip you with tools and a framework to accomplish lightweight business process mapping, and I just spent the last 10, 12 minutes promoting BPMN. To be clear, I'm not making money by selling BPMN. It doesn't cost you anything, and I'm not a member of their organization. We at Semaphore just truly believe that visual workflows represent a foundational shift in how laboratories perform their work, and in particular can control their innovation. And we believe it so deeply that we've chosen to fundamentally base our platform on that BPMN workflow concept. And that's because BPMN simultaneously addresses many common pain points that labs experience, but don't really have a good handle on how to address. Things like training and retention of staff, things like handling evolving compliance regulations, process enforcement, and most critically and most salient to this webinar, requirements communication. So let's check out what we need in order to get started with lightweight BPMN. First and foremost, this is a cheat sheet produced by Camunda, the company that makes the workflow engine that we use to build Labit. It's the thing that executes the process models that you're going to create. For me as a practitioner, it's a wonderful cheat sheet, but I would not call it lightweight at this point in time. You can get here, but this isn't what I'm getting to. It's got too many symbols to remember, and even though they're well categorized, I found that when I was first learning BPMN as a business analyst, probably, oh my goodness, 15 years ago now, it was counterproductive to try and use that entire visual vocabulary that you see here. Instead, this is the toolbox that I would utilize in a sales context to rapidly draw a picture, or like a lightweight context, to rapidly draw a picture of what a laboratory is trying to communicate to me when they tell me what they want their LIMS to do. You really only need to think about these 4 symbols in order to get started. The first one is a circle. What specific event causes something to start or stop happening? Draw a circle, give it a label like something complex like start or end, or maybe it's sample received even. That's, shows up in the laboratory. Make it clear, make it unambiguous for yourself. You can always iterate on it later. 2, where does that thing that you're working on or with go to next? That is an arrow or a connector. That arrow can be labeled too. Maybe it's passing a particular file to an instrument, for example, in which case absolutely label it with what that file type is. Maybe it's a CSV. Number 3, what is that activity that's going to transform the thing you're working on, the entity that you're working on? What's it going to do? Again, these can be real world entities like samples or instruments that have a physical presence in reality, or they can be virtual ones like files or pipelines or libraries or pools, really anything that you want to work on or transform. That's kind of the key point for what is an activity and what is not. And then finally, what decisions need to be made and under what conditions? The diamond is the perfect shape for this, because if you're like me, the arrow naturally goes into the left-hand side of the diamond and you have 3 obvious branches coming out of it. I personally get a little annoyed when there are more than 3 branches outbound, but that's my own personality quirk. Nonetheless, circle, arrow, box for an activity, diamond for a gateway or branch decision. Taken together and with a healthy dose of informality, you can communicate quite a lot with these 4 simple symbols. This is a real example, generified, I admit a bit, of what we at Labit call a communication diagram, which is a flow chart that we develop in whatever diagramming tool is most handy to us and the client. This one was done in Lucidchart, and I'll show it to you in Lucidchart in a moment. Its purpose is to communicate precisely what it is that they want in their informatics platform, what they want to accomplish. And here's the important part: end to end, from start to end, like the whole thing, regardless of what the actual phasing or scope of the actual project is. I just wanted you to see how these symbols can be used to assemble these things before we move to the framework. I'm aware that it's quite pixelated here. So to the real question, how can you, a laboratorian who has at this point probably only half a cup of coffee left, learn how to use these tools without getting bogged down in detail. And that's the key, though, I think, is not getting bogged down. And that's what we've tried to pull together here for you. This is not the framework, but the framework we have assembled from these blends together all of these, or some of these concepts rather, concepts from Agile, just-in-time, and many other lean concepts. The purpose of these lists isn't to explain all of the tenets of each methodology, but instead to point out that we're cherry-picking key concepts in order to enable us to move fast and produce good work without getting bogged down. Specifically, we're going to pull together the power of working in small increments, the best of Agile, along with a demand-driven approach to prioritization from that just-in-time approach, along with rigorous simplification, or actually more specifically in this case, abstraction, and then the idea of continuous improvement that's common across all of these types of things. And it might seem a bit odd, but we're going to explicitly reject the idea of having cross-functional teams at all times, as well as high-quality standards. That might seem counterintuitive, but there's a lesson to be taken from the adage, just enough, just in time, and just because. Specifically, we're only going to include enough team members to get the processes written down quickly, and then we're going to lower that quality bar so that we can rapidly iterate. We're doing that because we rely on peer review, which is one of the best things of Agile, I think. Think of peer review like a manifestation of something called Cunningham's Law, if you've ever heard of it. It states roughly, the best way to get the right answer on the internet isn't to ask a question, it's to post the wrong answer. Peer review of a completed diagram is kind of like that. You can rapidly collaborate on a completed diagram with your colleagues in order to get correct and ultimately approved answers. To be clear, I'm not proposing that you purposely capture incorrect processes and let your colleagues correct them. That's craziness. I'm just proposing that you trust in your colleagues' ability to review and rapidly identify errors from something that exists rather than starting with a blank page problem. So this is the core of our lightweight framework. It's really simple: prioritize, analyze, publish, repeat. But we need to expand that a bit in order to make sure that we don't get bogged down in what is almost always an interesting scientific rabbit hole that these conversations always produce. So first, how do we prioritize? I like to prioritize on the most used workflows first. More specifically, I've noticed across labs that there's usually one workflow, a set of experiments, or an assay that carries the bulk of the heavy lifting in the laboratory. That is the bulk of the work. And that's where I always focus first. There's a well-supported theorem out there that we use in business analysis. It's called the Pareto principle, which suggests that 80% of the outcomes happen from 20% of the inputs. But in this case, which of your processes support 20% of your, or which of your processes are 20% of the total number of processes, but actually produce 80% of your total work volume? Now that we've identified which part we're going to focus on mapping, what do we need to do in order to get through our analysis in a reasonable time frame? We split analysis up into 3 steps. First, we'll load up on context by reading or interviewing subject matter experts or having a conversation over coffee with our colleagues. Second, after loading that context, we're going to establish the major chunking of activities, or what the major branch points are. How many steps are there in this process, and where do things have to go, generally speaking, without too much worry about being precise here. Wherever possible, I try to keep the number of activities relatively low. So for lab work, I find that if you're getting above maybe 10 steps in a process, it's worthwhile to think about creating a nested workflow or a sub-process in order to abstract away some of that complexity. And then third, we're going to examine that resulting process for inputs and outputs into the process itself. So at the beginning or end, or even popping out the middle maybe, but then individually from within each activity in the process, those have inputs into one end and outputs out the other side. And what is that transformation that's occurring within that activity? And then finally, once we've done all of that and made our diagram, we'll publish what we've just completed. It might seem a bit trite, but it's actually one of the most important parts of this process. Publish in this context could mean a lot of different things. Use whichever one works for you. For me, it usually means asking a colleague familiar with the process to sanity check it, but it could equally mean pushing it into document control or Confluence or SharePoint or any other place you can put it so that others can see it and ideally use it. Once it's published, you can then zoom into any one of the boxes or sub-processes in your diagram or adjacent to that diagram and repeat the process until you get down to an irreducible activity. What's a framework unless it has a few guidelines, though, a few things of a few notes of wisdom to keep you from really rabbit holing in the wrong spots? First up, and from the Agile side of the concept camp, always create a time box for your analysis activities. For those unfamiliar, a time box is pretty simple. If you only have a spare 15 minutes, cool. That's how much time you can spend before you have to call this diagram done. Even if it's not finished, it's done for the purposes of this time box. I know this from my project management days. The work will always expand to fill the available time. So simply allocating yourself more time isn't necessarily the right answer. Create a time box, maybe an hour. Actually, for me, it's typically an hour, but that's neither here nor there. This is one of my favorites. Make sure you watch out for these in areas of your organization. I frequently see it. They rely on human memory or tribal knowledge, if you will. It's more common than you think, and anywhere you spot it, immediately try to turn it into a process because it's gonna produce dividends almost right away. And consider adding some scheduling to that process so that no one forgets, because ultimately processes can be scheduled and interdependent. One can kick off another, for example. So you can create a process to prevent over reliance on memory, for example. This one's a bit subtle. Wherever you can, use nesting or sub-processes like I mentioned earlier. In this case, I like to use it to encapsulate parts of the process that might be reusable elsewhere. A common one, for example, is sample preparation protocol. So you can have a branching process within your sample prep protocol to process whatever sample type is inbound and only execute the protocols that are appropriate for the sample type that's entered that protocol. Reusability also enables significant amounts of standardization if that's one of your goals. And sometimes we might have a blank page problem. Where do we even begin? Well, when in doubt, a good place is always your organization's policies, because policies by themselves are just documents that you read. But when you turn them into processes, you make them real, you make them actionable. And that's the whole essence of a lot of quality systems, actually, but I'm digressing just a little bit. It's worth noting too that processes tend to link policies together into a coherent whole. For example, a continuous improvement policy doesn't mean much unless you also have a quality policy to indicate what your organization deems worthy of a corrective action, which in turn goes to a continuous improvement process. And then building forward on that, and in case you've never done it before, it's sometimes helpful to create a rough map of the policies in your organization to understand how they work with one another. While it's not strictly BPM, like business process mapping, at the highest level, that policy map can be iterated upon to get to a list of processes that then need further refinement in later iterations. It's a great place to start. And then the final piece of this guidance of this and now not so lightweight framework is also, I think, the most important one. Perfect is the enemy of done. In order to save time and money on communicating requirements, you don't need your process maps to be perfect. You only need them to communicate the bulk of what you're trying to achieve. All of the consultants at both Semaphore Solutions and all over Astrix, they're all experts at finding those areas that need refinement, and in particular, those areas that represent risk. The purpose of this mapping that you're doing is really just to give them a cheat sheet to get started with so they can jump in quickly and understand what you're trying to accomplish. Let's jump quickly into the worked example. I'm running a bit over time, but here we go. So just to call it out, this worked example is purposely skipping part of our framework, that context load, because you probably don't want to watch me read a regulation. For this worked example, I'm going to use a relatively simple regulation that you saw at the beginning of the webinar. It's top of mind for clientele in the clinical diagnostic space. For those who aren't in that space, the FDA has recently published a final rule that asserts their regulatory authority over a class of diagnostic tests called lab developed tests, or LDTs. We're not commenting on the rule here. We're just going to run through the analysis of one of the regulations they have to comply with. There are 3 of them that they have to comply with in the next 6 months in the first stage. I chose the complaint files because it's got a low enough word count that we can get through it in the time we have available. So first up, we click on the link and we bring up the Code of Federal Regulations, and you'll see here I've screenshotted the first article of Title 820, subpart 198, and you're seeing that in the upper right, Article A in this case. Notice that I've put a blue box around receiving, reviewing, and evaluating. I would have done so after context loading it, of course. These types of words are a dead giveaway that they expect you to do something. So let's put that in our process by drawing, you see 3 boxes here, and then give it start and end events. The start event is we've identified a complaint. The event that kicks that whole thing off is that identification of the complaint. Could be an email, phone, or whatever. We're not actually specifying how it starts. It's just simply that it's been identified by a human. Article B states, and you see the things I've added here in red, Article B states that the lab has to evaluate all those complaints to see if they need to investigate further. And if they choose not to investigate, they have to annotate why. Starting with the annotation, we added that to the evaluation box as just a question of should this be investigated, and stated in simple words what needs to be documented before we moved on. You can also see I've added a diamond to represent a branch, as well as a box to capture the investigation protocol and the results of it. For clarity, I labeled the branch, and in practice, the systems that interpret these diagrams would automatically route the entities through the branch based on the fields set in the evaluate box, so we don't need to go any further. On to Article C, which states that you don't need to investigate a claim if you performed an investigation for a similar complaint already. That suggests a few things that we need to capture in both the receive and the review and evaluate stages. So I've added those into each of the notes, and then we've set it up so that if the complaint is materially similar to another complaint on file, you can just link them at the review stage, which I think makes a ton of sense here. It's certainly communicating the intent of the regulation. Next up, Article D, it adds on reportable event tracking, which simply states, if there's a death or a serious injury that's resulted from this complaint, we need to pay a bunch more attention. So we specify that we capture all of that at the first stage, and we'll flag it as 803 reportable if so, and then that also would have more information captured at the investigation step. I could have included a timer, maybe an indication of priority from the article for some, or excuse me, I didn't choose to include that for simplicity in this case, but you could easily add a timer to review, evaluate, and investigate steps to indicate that they have to be performed within a particular time frame. And finally, Article E, lower right now, adds specific information that has to be captured during that investigation, which you see I've added to the note in red. For good measure, I also added a message event, which is an intermediate event with that envelope you see in it. You can add pretty much any diagram you want. The professionals will turn it into real BPMN whenever you get it over to us, if that's what you're going to be doing, to indicate that the complaint is a reportable event and that it should therefore initiate the medical device reporting workflow, presuming you have one, of course. There are a few remaining articles in the regulation, but they speak mostly to multi-site access, and they left them out since that requirement's naturally handled by modern informatics on the internet, for example. And there you have it. In less than an hour of analysis, we've created a complaints management system that's compliant with 21 CFR Part 820. The really cool thing about this diagram is that it's BPMN, so it can be used directly in a modern informatics platform like Labit without any need to wait for the vendor to update their software to have a complaints management module, or maybe purchase a complaints management module. For those of you with regulated systems, because it's not a systems update, but rather a workflow configuration, you could make the argument from a risk perspective that you don't need to revalidate the system in order to deploy it. You can have it as soon as you model it, for example. I'm going to briefly jump from this relatively fast walkthrough of an FDA policy into that communication diagram I showed you at the beginning. But the point here is how quickly you can make actionable processes become real processes in your lab when you approach those workflows from a BPM perspective. So let's jump into that communication diagram, which means I have to switch things up just a little bit. I'm going to drop the slideshow, and here you're seeing, I hope, yes you are, good, the contract lab communication diagram. So this is a diagram representing a contract services lab to another provider, performing a basic PCR assay, and then in phase 2 they want to perform a sequencing assay. And you'll see here in different colors the different kind of phases that we have. Let's focus first on this bit in blue over on the left. You can see that we've got these operational workflows, or a phase 0. This is something that becomes really evident when you approach things from a business process modeling approach, where there's this common pattern that exists for areas that have long-lived entities in the system, this instrument or patient, if you will. An instrument's long-lived, it's maintained over time, and it's very infrequently retired. They'll live for a while, so you can add it, edit it, and then if you want to remove it, you would do so. They differ from the pattern that we see with things like consumables, reagents, or other kinds of inventory in your laboratory, which really just have one step: bring them into your lab and make them available for use by other workflows. When they are consumed, they then leave the laboratory. Moving over and calling out some interesting things for how we've worked with this diagram. You see workflow A, it was phase 1 of this particular project. We established what an accessioning or sample intake step looks like, goes through a branch into extraction, PCR setup. Then here's where I get a bit informal. I've dragged in a picture of the actual instrument in question, and I've also indicated, I don't know if you can see it there, that the arrows are labeled with CSV because we're just using a manual file upload in order to drive this instrument in the first phase for the sake of expediency. There'd be an automatic QC fail on the basis of some automatically evaluated QC parameter, and you see this little human on each of these tasks. It shows us that it's a user type task rather than something that is like a business rule or a service or a send receive message type event or a script, for example. Coming out of that QC fail, drops over into a reports approval. Ignore the rest of this for a moment, just the green. The approval workflow where they review the batch metrics, generate reports from templates. You could drag the templates in here as files, for example, and then you would approve and send those reports out and then complete. You can see here that we're using secure email in order to send those reports out. So already I, as a vendor, know almost precisely what the client's trying to accomplish. Furthermore, once we start talking about workflow B, or more specifically phase 2, you can see that we've got this, we're introducing a sequencing workflow, or a sequencing prep workflow in this case. Goes through your standard extraction, QC check, a fail back to extraction, through the various steps associated with an NGS workflow. Again, all manual for the first phase, or excuse me, for the second phase, until we get into a first fail situation. So after elution, we check with the qubit. If there's a failure, it'll be double checked by a tape station. Again, CSV in and out just for expediency's sake. Drops into another decision where if it passes, it moves on to pooling, but if it fails on sample volume, we check to see if we have enough sample in-house. If no, then we will contact the contracting organization. If yes, we'll go back to qubit and start the whole thing over, or maybe we'll start at library generation depending on what parameters we're checking. Moving over to pooling, you can see that we've created this thing, and then we check to see if we have a full plate before we move over to actual sequencing. If we don't, it goes into the freezer. We're going to store things into a freezer management workflow. I don't have one of those loaded up in here for the moment, but they're pretty straightforward. They look a lot like this guy right here, but there's probably a check-in and a check-out kind of a scenario. Once we have a full plate, over to dilution and plating. Again, still a manual thing, into a MySeq, using a CSV inbound. I forgot to label that one on this one. The MySeq then integrates into an AWS hosted secondary analysis under the labs AWS account using the FastQ and QC summaries. And then I'm annotating that the VCF, QC, and coverage files come back in to generate reports and leverages all of that. And so you end up with this diagram that communicates an incredible amount of information in a relatively short order. So there's quite a bit more, but because I'm running a bit low on time, I will jump back into the slideshow, and we're going to jump into key benefits before we then jump to questions. So in this case, in the webinar, we've tried to show you how to perform lightweight and informal business process mapping in order to create one of those types of communication diagrams. This process mapping is by itself quite valuable in helping to communicate goals and requirements, which in turn reduce that risk and cost of any informatics project. And that's due to how rapidly informatics professionals at places like Astrix or Semaphore or Labit can take this lightweight BPM that you've created and turn them into full formalized BPMN diagrams, and then use those in turn to configure a modern informatics system like Labit, or even a legacy one, even if they're not able to consume the diagrams. What you're seeing on the screen here are just some of the real and practical benefits currently being seen by Labit's clients because they're using BPMN, and possibly in part because of our software as well. Because some of them, let's call this out, because their processes are visual and live in their informatics systems at all times, they're seeing an increased user clarity of what's supposed to happen next, which in turn results in a reduced training time and a significantly reduced chance of error. And that's not only because it's clear what's next, but also because the BPMN provides process enforcement by nature of being in the informatics system. They're seeing benefits from live process documentation. If your BPMNs are live in your software, well, then your process documentation is by definition live. They're seeing benefits from, in terms of increased alignment between staff, and therefore also standardization across various multi-site labs, for example. The visual process maps also provide demonstrable process compliance, especially through complex process areas. And in turn, those complex process areas benefit from the abstraction that a nested sub-process can provide. Again, in this case, each phase that I showed you on the communication diagram could be a nested process or sub-process. And that in turn makes all of those things easier to understand. And then all of this is coupled with efficient change management and rapid process implementation, which is in turn enabled by the increased interdisciplinary alignment generated by everyone being on the same page, and also providing you a clear and unambiguous start and end state for any change activity that you perform on your informatics system, whether that's a full new implementation or just a modification project. In all, we at Semaphore are of the opinion that business process management, and in particular a BPMN forward approach to specifying lab requirements, will significantly reduce the cost of any given informatics implementation. I hope that this webinar has helped you understand how you can get started with lightweight BPM through the 4 basic symbols and iterative application of prioritize, analyze, and publish. I wanted to offer before we wrap up, though, that if anyone has a process map that they'd like to see running live in a demonstrated system, I'd be more than happy to help that attendee get them into formal BPMN and therefore into LabIt. But with that, and looking at the time, I'm going to wrap it up. Thank you, everyone. I think we're moving to questions next. Is that right, Kevin?
We are. Yeah, we are, Evan. Thank you very much. Great presentation. Let me do a couple things here real quick. First and foremost, we don't do recording during the questions, so let me get the recording stopped.